I'll post it on Blackboard, but I keep wanting to say Facebook, but anyway. But we will be having a review session in this room at this time on Monday, so you can just like forget classes are over and show up here. It's not required, but if you have additional questions about problems, that will be your chance to. It's okay. I won't be coming through again, so. It'll be in this room, 9. I'll be here for about 2 hours. I don't know if Mr. Sunkis is planning any.
I was going to do something.
Okay. Anyway, I will post it on Blackboard, but it will be here, Monday, 9. That's a study day, so everybody should be. I see some people looking shocked, or no?
Wait, it's a study day? There's no, like...
Monday is a study day. There are no exams. Yeah. Actually, probably yes. Or they need. Yeah, actually, bring several because I think we're going to do some simultaneously. So, okay. So, bring in your questions. Okay. So let me.
We refreshed the list, right?
We what?
Did we refresh the list, or was that last time?
The list never gets refreshed. So anybody, so they're.
No, we had one point where it's like we hit everybody, so we had to empty the list.
Maybe that was because somebody was absent. I'm not sure. Did you go up last time? No. Okay, because you're still down. In fact, you and Joseph are. Okay, let me just pull these out and get. So. And Joseph. Okay, so those two are the only two who haven't done anything yet, so they get shuffled. And choosing between 14.1 and 2, because we will do them separately. And then I'm going to call somebody up here to do a couple more of those since there's several in there. Okay, so, I mean, does it matter? Okay, so, Joseph, you get 14.1.1, and Sarah, 14.2. I got everybody's cards then, because now everybody's back in the mix. The very last claim day, we finally got everybody up there. Great. Okay. So 2 more people. So if you didn't list out separately, I'll just assume you claimed all of them. So James Tucker.
Is that right after or is that too late?
Why not try one of these black ones? So you're doing number 3.
Number 3 out of 4.
If you're 14.3. And Daniel is doing. Where's Daniel? Oh, Daniel's doing 14.4. So immediately goes off the do not call list, as does James. Oh, on the do not call list. Let's see, and that's probably enough. Well, we've got 5 slates, so Austin, you can do number 5. And you go off the do not call list. Okay, everybody down here gets to multitask. Study each one. Some of these have not much to say about them. Just hang on up there until we get everybody done. See if there are any questions. Actually, I think I'll add something to this problem for the next group of victims. I mean, students, I will ask if it's an equivalence relation, what are classes? What are the equivalence classes? So why don't you think about that, Joseph? What do you think? What is the? I'm going to ask you to describe the equivalence classes of these. Well, just know what are the equivalence classes. So if you pick up any real number, what are the things that are equivalent to it? Yeah. So you have this relation, right? Okay. And the relation x is related to y means that x squared equals y squared. So let's start with 0. What are all the things that are equivalent to 0? Okay, so 0 bar is, well, there's only one, right, in R, so but 0 bar is a set, right? Okay, so it's a second ending 0. Okay, what about 1? What is the equivalence class of 1? Not in this equivalence.
Real number?
What are all the things whose squares are equal to 1?
1.
And? Yeah, so 1 bar is plus or minus 1. So if you pick up any x, what is x bar in your equivalence relation?
Would be natural numbers and 0.
Well, you told me what the equivalence class was for 1. It was the second thing plus or minus 1, right? So if you have any x, how is that going to be different? What are all the things that are equal to the square of x? Just be plus or minus x, right? Okay? This is worth, in all these problems, when you have an equivalence relation, you should think about what the equivalence classes are, because that's something I could certainly ask you about. Okay, so are there any questions about Joseph's one there? That basically follows from the fact that equals is an equivalence relation, right? And you have several like that. So, but you should be able to think about what the equivalence classes are when it's yes in every case. Okay, so I guess you're done.
Sorry about that.
What's that?
Sorry about that.
Oh, no, that's okay. I went. You were called to go above and beyond. So. Okay, Austin. That blue is really hard to see. Okay, so yeah, let's just hide that blue. Well, no, don't rewrite it. I mean, is everybody okay? I mean, if I move over this way a little bit and get out of the glare, I can see it. Okay. Okay.
It's not symmetric. It is transitive.
Okay. So when the answer is no, you need to give some kind of concrete
example.
Yeah.
X2. Say if I flip x1 to x2, that won't work for all cases. And if you want me to give you a specific.
Yeah, so that's why, because it doesn't work in all cases, and that's why you have to be a little careful with that. So just let x1 be something and x2 be something.
X1 can be 1 and x2 can be 2. So in the symmetric case, it would be 2 is less than or equal to 1.
Exactly.
Not true.
Okay, so once again, when the answer is no, you should be thrilled, because you don't have to prove anything, you just have to give an example. I mean, you know, you can't, even though some of you still want to try, you can't prove something by a single example, right? But you can disprove something by a single example. That's all it takes. Okay, so, yeah, and so the transitivity of the last part, actually that was an earlier exercise, remember when we had, because you got transitivity for less than, but there was one where you had less than or equal to things that were done back in the section on order axioms, right? So, okay. So any questions about number 5? Okay. Let's try number, let's see, I guess we'll just go in order of whiteboard slates. Okay, so. Okay, go ahead. Daniel.
It is reflective, it's not symmetric, and it is transitive.
Okay. And you've got, so why don't you give some more details?
Alright,
as
well,
you,
reflective is easy. The set takeaway itself is the empty set, even if the set is empty itself. Symmetric, I said that A is 1, then B is 1, 2. So A takeaway B is the empty set, but B takeaway A is just 2. Then transitive, if A takeaway B is the empty set and B takeaway C is the empty set, that means that if an element is in A, then it is also in B, and then if an element is in B, then it's also in C. Therefore, we can say that if the element is in A, then the element is in C, so the set A takeaway C is empty.
questions about that last one?
Shouldn't it mean that A takeaway B means that X is an element of A, but X is not an element of B?
No, the fact that it's the empty set. Yeah, because it's empty.
Okay.
So let me think about this last one for a second. Yeah, so did anyone have a different answer for the last one?
I have a form, but it's basically the same argument.
Yeah, okay.
I think I was going to mention that, like, if A not B is equal to empty set, then it's a subset of B.
Yeah. Okay. Yeah, so I mean there are other ways. Okay, so this is reasonable. I'm just looking over the argument. Right. Okay. And the point is that it's not symmetric, which is why it seems a little weird when you twist it around. Okay, so yeah, so you can also write, I guess the point is you can also write A takeaway B is A intersect B complement, and you can also use the fact that it's a subset, so there are various ways to do this, and this is a direct kind of argument for that problem. So, questions about this one? Okay, we did 414. Thank you, Daniel. Okay, so let's move on to 414.2. That was you, Katie, was it? Right?
Sarah.
Which? Sarah, sorry. Oh, your sister. Okay. Sarah, go ahead.
We're just gonna explain it.
Mm-hmm.
So for all sets of people, P related Q, and P and Q share one parent. Well, P technically shares both parents with P, so of course it's reflexive. The relation is reflexive. P sharing one parent with Q is the same as Q sharing one parent with P, no matter which parent it is. So the relation is symmetric.
So I think it would be better to with the symmetric to be. So I mean, can you word that, starting with suppose P is related to Q, and then say what that means? And I mean, I'd like to. Well, don't erase. Just have a go over the other slate.
I go over here.
Yeah. And the reason why I'm making you do this is I want everybody. I keep seeing in office hours that some of you are getting stuck on some problems because you're not sort of latching on to the opening line, right? And some of these are kind of straightforward, but remember the symmetric is an if-then statement, And so your opening line for that is always going to start with supposing that P is related to Q. And you know, I believe what you wrote there, but I just wanted, okay.
Would it say like, which is the same as?
Yes, then I would just say,
That?
okay, yes. So, okay, questions about this? Okay, transitive, we might need to talk about this a little bit, okay? So go ahead and say what you said there.
I guess probably would be better phrase is suppose, but if P and Q share a mom,
Yeah.
and Q and Z share a dad, then P and Q do not share a parent, so it's not, so the relation is not transitive.
Okay, what if P, Q, and Z